You're listening to DTF Intro for March 5th, 2026. I'm your one from the compile host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where people go to feel bad about how much they haven't shipped yet. The energy today is, go build it yourself and do not ask permission. 10 stories. Clocks running. There's a design decision you run into eventually in any complex pipeline. How many handoffs can you afford? Every boundary between system. Every place where data changes format, crosses a process, gets serialized and deserialized, is a place where latency accumulates and fidelity degrades. You learn this the hard way. Usually when something at step 3 is failing on information that existed clearly at step 1, but got lost in translation. Voice assistants have lived with this problem since the beginning. You speak, ASR strips your audio down to text, discarding the prosody, the hesitation, the emotional register. An LLM reasons over that flat text. TTS reconstructs something approximating natural speech from the other end. 3 models, 3 handoffs, cumulative latency, and meaning leaking at every seam. PersonaPlex 7B collapses the pipeline. Audio in, audio out. 1 model, no text intermediary. Based on Qtai's Moshi architecture. It processes 17 parallel token streams at 12.5 Hz. With a 7B temporal transformer reading the unified audio context and a deformer generating output codebooks sequentially. The result runs at RTF 0.87 on an M2 Mac. Faster than real-time, under the 80 milliseconds frame budget. Full-Duplex, it listens and speaks simultaneously. What Ivan's team published this week is a native Swift implementation running via MLX on Apple Silicon. The original Nvidia checkpoint is 16.7 gigabytes. They converted and quantized it to 4-bit, brought it to 5.3 gigabytes, and published it on Hugging Face. The deformer alone dropped from 2.4 gigabyte to 650 megabytes in the process, with no measurable quality loss on ASR round-trip tests. Conversion script included, fully auditable. Now, apply the architecture question, who holds the off switch? Nvidia published the weights. The quantization is open. The Swift library is open. The Hugging Face model is public. This runs on hardware you own, with no inference endpoint you're dependent on, no API rate limit, no terms of service revision that changes what you can build with it. The HN comments are interesting on this. People want tool calling, want better multilingual support, want diarization. All reasonable. WhisperKit just added TTS with speaker diarization support, which is a different trade-off. A modular open stack versus a single unified model. Both paths exist. Both are reachable without a commercial gatekeeper between you and the capability. That's worth naming. A 7B full-duplex voice model, faster than real-time, running natively on your laptop. 2 years ago this was research. Today it's a Swift package on GitHub. Local inference, no gatekeeper. Story 2. And now we take that same energy to your inbox. There was a brief window in the early 2000s when technologists believed the web would become self-describing. WSDL, UDDI, the whole WS star stack. Services would publish their own capabilities. Tools would discover them at runtime. The vision was sound. The execution collapsed. UDI registries went dark. WSDL parsers became a running joke. The dream of the self-describing service died by committee. Google Workspace CLI. Cheetah as a is a quiet reinstatement of that dream, done right. The architecture is worth sitting with. Sitting with doesn't ship a static list of commands. It reads Google's discovery service at runtime, constructs its entire command surface from what the API actually exposes at that moment, and presents it to you, or to an AI agent, as a coherent interface. When Google adds an endpoint, GWS inherits it automatically. No update cycle, no version skew between the CLI and the API it wraps. Run that principle all the way. If the command service is derived entirely from the API description, the CLI can never be wrong about what the API supports. The specification and the tool are the same thing. Anyone who has spent an afternoon debugging a client library that lied about what the server actually accepted knows exactly why that property matters. The 40-plus agent skills bundled in are the other half. Structured JSON output, consistent pagination, dry run support. These aren't conveniences, they're the affordances that make a CLI legible to an LLM without a custom adapter layer. The agent reads the schema, calls the tool, gets back data it can reason about directly. No parsing, no inference, no brutal string matching. One commenter named the real friction. You need a GCP project to authenticate. That's not trivial. The tooling helps. GWS or setup can walk you through it. But the credential floor is real, and not everyone will clear it. Still, the project is open source, the architecture is principled, and the underlying idea. Let the API describe itself. Let tools derive from that description. Keeps proving itself right whenever someone attempts it with care instead of committee. Self-describing systems failed in the 2000s because the incentive to maintain the description wasn't aligned with the incentive to build the service. Google maintaining its own discovery service for its own infrastructure removes that misalignment entirely. The dream wasn't wrong. The context was. That self-describing API dream took 20 years to land right. Story 3 is about another old wound, finally getting the surgery it needed. Make the strongest possible case for the maintainers first. Charday has been LGPL for years because it started as a port of Mozilla C++ code. Not by design, but by inheritance. The library is genuinely excellent work. A statistical character encoding detector that handles obscure encodings with real elegance. Corporate users avoid it anyway, and that LDBEL friction is legacy weight from a different era. The argument for cleanroom via AI is principled. Cleanroom doctrine protects against expression transfer. And if an AI produces functionally equivalent code with genuinely different expression, isn't that precisely what a clean room produces? The argument fails on its own terms. The two-team clean room structure. Team A documents behavior, Team B writes from spec without seeing source. Exists because courts don't trust humans to isolate what they've absorbed. That wall is an epistemic proxy. The problem isn't copying. It's contamination of the knowledge process itself. Once you've read the original code, you can't unknow it. Feeding LEB8 source to an AI and asking for a rewrite doesn't bypass that contamination. It amplifies it. A human engineer skims for architecture, then makes independent implementation choices. The model processes every expression, every identifier, every comment. Building a representation of the original more precise than any human reading. The exposure isn't incidental. It's total. This is the Sabid fallacy in professional kitchens. Cross-contamination between raw protein and ready-to-eat food can't be resolved by cooking technique downstream. The organism transferred at contact. Precise temperature control doesn't walk that back. The contamination event is exposure, not output. Then, the Supreme Court handed the maintainers a second problem. By declining the AI copyright appeal on March 2nd, the court solidified human authorship as a legal requirement. That creates a genuine double bind. If AI-generated code can't be copyrighted, the maintainers may lack standing to license V7 Mind Deal under MIT or anything else. They escaped one constraint and fell directly into a void. 3 failure modes. Derivative violation, ownership void, copyleft, erosion as precedent. All point in different directions. The Charday maintainers may have believed they found a technical workaround for a legal problem. What they found was a new category of legal problem that didn't exist last year. The tools for asking these questions at scale arrived before the frameworks for answering them. Every project doing AI-assisted rewrites right now is carrying legal exposure that won't be measured until a court takes a serious case. That gap is going to matter. What if the model helping you rewrite your code base isn't just legally uncertain, but factually uncertain about everything it's telling you? What would a sourcing requirement actually do to the LLM industry? Run it forward. Every inference pass produces provenance alongside tokens, a heat map of influence, which training examples activated, in what proportion traceable to origin, not citation cosplay. Actual pointers, the source code of thought, auditable. The technical obstacles are not small. The author of this piece makes the point plainly. Citation in current models is pattern completion. LLMs cite things that are frequently and correctly cited in their training data. They don't look anything up. The weights digested the sources and return statistical averages. And this is the bemusing part. Exactly as designed. The indistinguishability between citation and hallucination wasn't an accident. Shadow libraries, open code repositories, scraped without consent. Creative work blended until nothing is traceable. The architecture doesn't support attribution because it was never asked to. The business model required ambiguity. Plausible deniability is a feature you engineer in at the training run, not something you discover later. Run the alternative forward. What does backpropagation look like if weights have to carry provenance? What does infer quantization look like if you need to store attribution alongside parameters? The entire pipeline was designed for a world where sources don't need names. Retrofitting that would require not just new architecture, but new economics. And a commercial incentive to build honestly that has not yet materialized. One comment in the thread actually landed. Someone noted it's a double entendre that code, unlike art, doesn't suffer from reuse. The article uses this to argue code is categorically different from creative work. What it actually reveals is how much of what passes for engineering is undifferentiated assembly, and how attribution requirements would make that legible in ways that make everyone uncomfortable, not just the AI companies. The developers whose vibe-coded output strips original authors, licenses, and links before shipping it has their own. The author calls for LLMs to cite sources properly. That would require building a fundamentally different kind of system. One that was never commercially interesting to construct. The fact that it would also be more honest is, apparently, insufficient motivation. Attribution is technically hard. Opacity was technically easy. The architects knew which one they were building. Story 5 is a palate cleanser. And honestly, a gift. We're going back to where so many of these ideas were born. The screenshot that stops you is from 1980. 4 panes: package list, class list, method, category, method, body. Then the author shows you a screenshot from Faro. Modern polished dark mode optional. And it's the same 4 panes, 40 years of computing compressed into one visual rhyme. Play it the other way for a moment. The browser should have been killed decades ago. Message passing systems don't need hierarchical browsers. They need message flow views, tools that let you trace behavior as a path. Follow the conversation between objects as it actually unfolds at runtime. That's what the architecture demands. That's the obvious next step, except it doesn't work. And the reason it doesn't work is subtle enough to miss on first read. A message, isolated, is context-free. You can see it fire, you can see what it returns, but you're looking at a sentence without a paragraph, a function without a module. The method lives inside a class. The class lives inside a package. That structure is not bureaucratic overhead. It's how you know what the code means. Strip the hierarchy, chase the flow, and you've traded context for motion. You can follow the path. You just don't know where you are. So, the 4-pane browser survived because it was right about the one thing that matters most to a working programmer. Location. Where am I in this system? The unintended consequence is exquisite. Smalltalk invented live inspection, tight feedback loops, image-based persistence. Things modern IDEs are still catching up to. Then it got pinned by its own best idea. The browser is so precisely correct at providing structural context that nothing could displace it. Even as the job it was asked to do expanded far beyond what 4 panes can hold. The author's screenshot of the Windows tsunami. A cascade of browsers opened while tracing one simple question. Is the system working exactly as designed, producing exactly the wrong result? Every window is locally coherent. The composition is chaos. That's the real problem, not the browser. The browser is brilliant. The problem is that brilliant tools, composed badly, become their own kind of trap. The scene doesn't fit in the frame, and the frame was never designed to be composable with other frames. 40 years on, that's still the open question. 5 stories, Nida, and we've gone from AI inference to medieval archaeology. Pause. Today's lineup is genuinely unhinged in the best way. Story 6. 300 years of silence. That's what the dark ages of Sudanese history means in practice. Not darkness exactly, but absence. Old Dongola shrank from a capital city to a citadel to a name in fragmentary texts. And the rulers who governed that shrinking world became at best semi-legendary, preserved only in oral histories compiled centuries after the fact. Then, someone excavated a rubbish heap. The document recovered from building A4 in Dongola is not dramatic in its content. A king named Kashkash issues an order. Give Muhammad al-Arab a 3 of something. The word is still being worked out. Receive a ewe and her offspring, collect from Abd al-Jabir. Give 3 cotton cloths. Administrative minutia. The scribe Hamad wrote it. Greetings. What makes it extraordinary is the confirmation cascade it triggers. Oral tradition had preserved Kashkash's name in a 19th century biographical dictionary, where he appears as the great-grandfather of an important holy figure. The genealogy existed. The person it pointed to did not. Verifiably. Now he does. This is the archaeology of discard at its most precise. What people throw away is often what survives. Not the monuments, not the official records. The scraps, the working documents, the notes that weren't worth keeping. A livestock transaction from a rubbish heap becomes the anchor for 3 centuries of uncertain history. The bootstrappism angle here isn't about software, but the principle holds. Knowledge systems only liberate when they're accessible. The Nubian corridor connected the Mediterranean to sub-Saharan Africa for millennia. gold, ivory, ideas, religious models, all moved through it, and yet historiography treated it as peripheral, a gap between better documented civilizations. The lead researcher puts it plainly: Nubian communities weren't passive recipients of influence. They actively shaped the flows passing through. That's a different story than Dark Ages. What the project is doing? Systematically excavating a site that oral tradition identified as the royal residence. Is the practice of taking non-European historical sources seriously as primary evidence. The oral REH cord pointed to a building. The building contained a document. The document confirmed the name. 3 systems, none designed to interoperate, accidentally composing into a proof. That's the kind of result that makes you want to dig more rubbish heaps. 3 systems composing accidentally into proof. That's the open source energy. Story 7 brings the same spirit. Someone rebuilding what was lost. One commenter on Hacker News has been saying it for 15 years. The world needs something exactly like Flash. The precision matters. Exactly like Flash. A developer on Newgrounds just posted what might be the answer. Strip Flash down to first principles. What was it, actually? A unified authoring surface where drawing, animation, and scripting shared the same coordinate space. You drew a shape, turned it into a symbol, attached a script, tweened it across a timeline, and exported a self-contained artifact. The tooling was integrated not by accident, but by design. The authoring environment and the runtime were the same mental model. Adobe killed Flash in 2020. What replaced it for 2D animation authoring? Nothing that closes the loop the same way. Animate CC exists, but it runs on Adobe's continued goodwill and your subscription. The open alternatives. Some fake open tunes are powerful, but they are animation tools. Flash was a creative development environment. You could write code. You could build interactive things. You could ship. What this developer is building. In CTOL with Evilonia and Skagashap cross-platform from day one. Closes that loop. The technical choices are worth examining. The vector engine uses a doubly connected edge list, which is the data structure that made Flash's merge drawing mode work. Shapes that interact, that eat into each other, that compose geometrically. He's implementing all 5 of Flash's original paint modes. This is not someone who studied Flash from the outside. This is someone who understood what it was doing at the geometry layer and rebuilt it from that understanding. The DTFLA import is the headline. Your old Flash files, the ones from 2004. Open them, edit them, continue working. He describes it as the only open source tool that functions as a full authoring environment and can actually import .fla files. Not just render them, edit them. That's a 20-year archive suddenly reachable again. The scripting system runs on Roslyn, the actual C compiler. He's planning an action script to C transpiler so imported scripts don't arrive dead. Authoring time scripts with real tooling behind them. One person built the vector engine, the timeline, the symbol library, the sound editor, 17 drawing tools, and .fla import. A commenter at Adobe said they built a Flash crawler back in 2008 just to index what existed. Someone else linked their old Newgrounds profile like they were showing a scar they're proud of. The tools exist. Put them where people can reach them. What happens when that kind of democratized tooling meets hardware that finally delivers AI on every desk? Story 8. 50 trillion operations per second, and you can't buy it at Micro Center. AMD's first desktop chip with a real NPU, the Ryzen AI 400 series, lands today in AM5 socket systems, and the distribution story is quietly significant. These are Pro SKUs, business only, the kind of chip that appears in corporate desktops managed by IT departments, procured through channels that don't involve a shopping cart. AMD will not be offering boxed versions to regular consumers, the hardware that unlocks local AI inference on a desktop. No dedicated GPU required, no cloud subscription, no data leaving your machine. Is going straight into conference room workstations. The historical parallel worth sitting with. This is almost exactly how the math coprocessor transition played out. Through the late 1970s and most of the 1980s, floating point computation required a separate chip. The Intel 8087, the 80 Wamber, H7, the 8030 specialty hardware, expensive. Present in workstations, absent in most consumer machines. Then Intel put the FPU on the 486 die in 1989. Floating point stopped being exotic. Compilers started assuming it. Within a decade, the capability was invisible. Just part of what a processor did. Nobody called it a floating point PC. The NPU trajectory is running the same script. 15 years compressed. AMD put NPUs in laptop chips, starting in 2023. Now they're in desktop silicon. The performance number, Wuda Zhoupeng, clears Microsoft's Copilot because threshold, the architecture. Zenfone CPU cores, RDNA hard graphics, MPO and 1 die. Reflects AMD's read that local inference becomes as ambient as floating point arithmetic, not a specialty workload, just what processors do. One commenter pointed to the framework desktop running a Ryzen AI Max, plus with the 120 gigabytes of unified memory available to the GPU. That machine can run a 1 trillion parameter model locally. That's available hardware today. The barrier isn't the silicon anymore. It's RAM cost. Unified memory is still expensive and the comments are full of people watching component prices. And it's channel access. When the most capable desktop NPUs are locked to enterprise procurement, the tools exist, but the reach is constrained. That gap closes. It always does. And it closed fast with FPUs. Consumer chips had integrated floating point by 1993. The question is what gets built once this capability lands in every mid-range desktop. Sitting there ambient, waiting. That day is closer than it looks. Moving on. Building an image processing pipeline teaches you something immediately. The naive path collapses at the edges. Tune for average luminance and you've optimized for nothing. Noon sunlight blows it out. Basement birthday parties go dark and flat. The system that actually works is the one that measures first, then decides what correction to apply. Every line of this project knows that. Here's what's actually in here. A Raspberry Pi. A thermal receipt printer. The kind behind every coffee shop counter, with the slick paper you can scratch with a fingernail. 3 GPIO buttons. Shoot, reprint, shut down. And an image pipeline that branches on brightness. Below 60, histogram equalization. Below 90, gamma correction at 0.7. between 90 and 110. Clay Hay. Contrast-limited adaptive histogram equalization, which handles local contrast without blowing out highlights. Above 130, contrast stretching between user-defined bounds, each branch doing exactly the right thing for that lighting condition. That's not a weekend hack, that's considered engineering. Someone worked out what actually degrades on thermal paper, which has no color-limited dynamic range and a resolution ceiling, and built adaptive pre-processing tuned specifically to those constraints. The printer becomes the design constraint that shapes everything upstream. The question everyone skips past in the comments is the interesting one. Someone points out you can buy a toy thermal camera on Amazon for $20. And they're right, you can. So why build it? When you build it, you own the whole stack. You know why the gamma is 0.7 and not 0.5. You know the threading model. Why the button callback spawns a daemon thread instead of blocking. You know the USB vendor ID for your specific printer. You know what brightness value triggers which branch. You can change any of it. The $20 Amazon camera is a black box with a button. This is a system you understand. That understanding generalizes. The person who built this camera now has an intuition for adaptive image processing, GPIO interrupt handling, thermal printer constraints, and embedded Python on ARM. The person who bought the Amazon camera has a camera. One of those things compounds. The tools exist, the knowledge is available. The only thing this project required was someone willing to read the library docs and close the loop. And at why, the docs, the code, the freedom to close the loop, depends entirely on what happens when someone tries to take it away. In Untitled Phoenix Technologies needed a PC-compatible BIOS. The problem: IBM owned the copyright on the original. Phoenix built a wall. One team read IBM's code, documented everything it did. Every interrupt, every routine. Then walked away. A second team, who had never seen the original source, implemented from those specs alone. The wall was real. No code crossed it. The result was legally clean. A genuine independent creation. Functionally identical, legally distinct. That's what clean room actually means. 2 rooms, no windows between them. Charday's maintainers did something different. Version 7.0.0 arrived with a new license. Not LDEBA, something else. And a claim. Complete rewrite. Clean room. New work. Mark Pilgrim, the original author of Charday, the man who wrote Dive into Python and then famously vanished from the internet for a decade, reappeared this week in a GitHub issue to say, no, the agent writing the rewrite could see the original license code. That is not a clean room. That's a room with a very large window. The engineer in question we're sitting with, when the code generator had full access to the original LGPL source, where exactly does derivation begin? Copyright law is famously fuzzy here. The Oracle v. Google decision showed that functionally identical APIs can be considered independent, but LGBA carries specific obligations about modification and redistribution that go beyond typical copyright. The license is the architecture, and architecture, as we keep learning, determines outcomes. The discussion has predictably sprawled into every possible edge case. Clean room doctrine, the Oracle precedent, whether all AI-generated code is now perpetually tainted because training sets ingested GPL'd software. That last question is genuinely unsettled and genuinely interesting. But it's a distraction from the immediate issue. The maintainers made a specific claim about their rights that the original author is specifically contesting. The bemusing part is the complete rewrite framing, deployed like a magic spell. Rewrite thoroughly enough, say the words, and the license obligations evaporate. That's not how LDPAL works. The obligation attaches to the act of modifying and redistributing covered code, not to how elegant or thorough the modification was. Chart A is one of those invisible load-bearing pieces of the web. Encoding detection, quietly handling 30 years of character set chaos so the rest of the stack doesn't have to think about it. It deserves better than a realist sensing move that could have been avoided by either building a genuine clean room or simply asking the original author first. Pilgrim asked politely. He said, respectfully, "Run this forward and hope the maintainers listen." This has been your daily tech feed for Hacker News for March 5th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something you actually understand. We'll see you back here tomorrow.